In this lesson, you learn to make asynchronous Web API calls. The objectives for this lesson are to find out what is asynchronous. We'll see the difference between synchronous versus asynchronous. We'll talk about asynchronous and Web API calls by taking parts of our program that we've already written and making it asynchronous. So first off, what is asynchronous? Well, it means that we're creating a task that runs in the background. So your program can continue to process other requests even though this other task is running in the background. It's really useful when you need to perform some method that takes a lot of time to process. So we can run many tasks in the background typically. So that's, at a nutshell, what asynchronous is all about. To put it in some context, think about a web browser where you navigate to a web page and the HTML just seems to come up right away, and then maybe other things fill in. Well, that's because downloading of images is actually done on a separate thread. So the HTML comes down on one thread, the images are loaded on another thread. Maybe you're downloading some scripts, that could also be done on another thread. Now, there are only so many threads available within a web browser, but this is how it works behind the hood. Normally, our internet is so fast these days, we don't even know this is happening. But if you were actually to go into the F12 browser tools, you could actually watch this happening. So what's neat is that part of the page can be seen while images are still being loaded. The user can type into the browser and you can go somewhere else completely before the browser has even done loading that page. This is an excellent example of asynchronous programming happening. If we were to consider a synchronous example where the user makes API calls to get a set of maybe 10,000 products, I mean, that could take a lot of time, right? The problem is if we're doing this synchronously, while that request is being filled and made, that user can't do anything else within the program. He's basically stuck. Now, if we were to convert this to an asynchronous sample, the user makes that same call to get a set of 10,000 products, but that task is actually put onto a background thread so that it can process and wait for that data. In the meantime, while that task is going on, the user can do other work within the program. When that background task finishes, then an event can be raised and then the results can be displayed somehow. What's nice about this is it really keeps the UI responsive. It doesn't mean you're necessarily going to go faster. It just means that the user can go on and do other things while other things are happening. Now let's kind of put this into terms of a web API. So if we're talking synchronous, let's say we assume there's two threads in what's called the worker pool, right? And request one comes in and it's assigned to the first thread that's available to run our API calls. Thread one is now blocked until that request is finished. Then request two comes in and is assigned to thread two. Well, now thread two is blocked until that request is finished. So if request three comes in, what happens? Well, request three has to wait until either request one or request two, either of their threads are finished processing their tasks. Now, if we take that same example of assuming two threads in the worker pool and an asynchronous call comes in, request one comes in and is assigned to thread one, but thread one submits an async database call and then releases the thread back to the pool. So now we got a background task going on, but the thread is now free. Request 2 comes in and is assigned to thread 2. Thread 2 submits another background task to do some sort of database call, and it too releases the thread. So now when request 3 comes in, it can be assigned to thread 1. Maybe request 3 just retrieves a static HTML page. It can return it and then releases that thread. And then when either of the other async calls are done, they are assigned back to an idle thread, and that data is then sent back to the caller. Now, this does not necessarily make your APIs run faster. I mean, if you think about it, it takes the same amount of time to get that data from the server. That doesn't change. What it does do is it can increase how many requests can be made to your web server, right? So it increases the scalability of your web server, and this is called vertical scaling. Horizontal scaling means you're adding more web servers. Well, that's not always viable. So if we can use this asynchronous, we can actually increase the scalability without adding more hardware. So let's get down to the mechanics of how this actually works in the Web API. Well, we use an asynchronous keyword that we attach to the method so that we're telling .NET, hey, we want you to make this an asynchronous call and then actually use a background task when we tell you. So we use the await keyword to yield control of the thread. So when we say return await task.run and then call this get method, and let's say that's the one that's going to go out and retrieve 10,000 rows. Await doesn't mean wait. It means I'm releasing control of the thread so that this background task that's out there running on some other thread of execution can go on its merry way. And then what happens is right after that line of code, the get goes off and starts processing, but the console.write line, boom, it goes right away. So the async and await are the two keywords we're going to be seeing and using throughout the rest of this lesson. So what is this task? Well, it's basically an object in .NET that allows you to execute some sort of operation asynchronously. And that task will return a value. It could be a single scalar value. It could be an object. Now work then is performed on some other thread in the thread pool. And we have properties that go along with this task object. There's a status. There is the task completed. Is it canceled? Has it been faulted? And we usually start these tasks with task.run or task as the generic .factory.startNew. I want to show you just a small little console application to further drive home the difference between synchronous and asynchronous. What I have in this little console application is a product class. I then have a product repository, and I have a get method in here that simply is going to return a list of products. Now, notice what I've done here. I've done a thread.sleep for about 2 seconds. So I'm just simulating some long process happening. And then I've got a list of 4 products here. Pretty simple. But let's look at the program here. What I've got now is I'm going to come into this program.cs. I'm going to do a var repo equals new product repository, console.writeLine, starting synchronous task, var list equals repo.get. Then afterwards, I'm going to say it's complete and I got so many back from this list, and then we're done. The synchronous task is done. So let's run this. There's the start. Remember, we paused for about 2 seconds, and then finally it's complete. There's 4 things on the list, and we're done. But you saw that we had to sit there and wait for this. Well, now let's take a look at the other sample that I have in here. So I'm going to comment this code out. And let's go ahead and uncomment all of this code. And let's take a look at the product repository one more time. But now let's take a look at the getAsync method. Now what I've done is I have async keyword attached to the getAsync. I'm now returning a task that's an IEnumerable product. So I'm not just returning a list, I'm returning a task, which eventually will have a list of products in it. Then I return await task.run. So we're saying, hey, task, go ahead and run this get over here. Remember, that's the 2-second one. But I'm going to yield control. So there's nothing going to else happen here. I'm releasing control back to whoever called me. So right here, I do the console.writeLine again. I call this, but now guess what? It immediately starts going here. And we say while not task.is completed, because we got back a task object. I can now write to the write line doing other stuff, and we'll see how long this takes until it's finally completed. And then when it is completed, we'll say getting the list. So we now can go after this task.result.toList. So we hit the result property to get our value. And then we can get the count, and then we'll finally say after the async task. So let's go ahead and run this, but I'm going to put a breakpoint right here. So let's run this. Okay, doing other stuff, doing other stuff, doing other stuff, and then boom, we're done. So while that task was not completed, we were in here. Then it finally was completed. We then spit this out. We ended up here, and now we will see in our console window. There we go. Look at that. So then it says getting the list complete and after this async task. So there's other stuff we could have been doing, right? I just did a while loop just to show you. But think about that while loop as being, well, I'm just a web API. I'm going to go ahead and release that thread back to the worker pool, and then I'm just ready for somebody else to come in here and do something. Let's now apply these asynchronous techniques to our web API project. We're going to create an async repository class, and then we'll add our getAsync method. Open the iRepository interface, And what I'm going to do is up top here, I'm going to add the asynchronous versions of the methods that you see below. We'll do them one at a time here. Now, I would have to go into the product repository and I'd have to add now a getAsync method, but that would make this class quite large. So I think what we'll do is we'll do this. Let's make this a partial class and we'll have this synchronous access to the product methods. Then let's go ahead and right mouse click on the repository layer here and add another class. And we'll simply call it product async repository. However, all it's going to do is it's going to basically be the same class. It's going to be the asynchronous methods, but still the product repository. It's all the same class, right? They just get combined by the compiler, but this allows us to separate things and keep things a little bit cleaner. So now I've got this getAsync method here, and look at what I've done. On line 16, I do a public async task list of product. So it's not like the product repository where the get method is simply public list product get. It is now returning the task. And then look at the return statement. Await _dbcontext.products.orderby to list async. So I've just simply turned this into asynchronous code. Luckily, Microsoft built all that into the entity framework, so we now have the ability to have asynchronous versions of our data access. Let's now create an asynchronous controller. Right mouse click on the controllers folder and let's add a new class. This one we will call product async controller. It's going to look like all the other controllers. It's still going to have the route attribute, the API. It's still a product async controller that's going to inherit from our controller base API. We still inject the same things. The only difference is the same thing like we did in the repository class. Line 31, public async task. There we go. That's it. And then look at line 39 where I do var task equals await _repo.getAsync. So that gives us back that task. So then we just need to now return it when that is done. So we do that by doing the list equals task.toList, and then we return that using the status code 200. But all the rest of the code is exactly the same as we have in our product controller. All right, let's try it out. Let's run this. Now, as I mentioned before, this doesn't necessarily speed everything up. All this does is gives us some better scalability. So let's go ahead and execute this. It should produce the exact same results as the other one. And feel free to combine this if you wanted to. You don't have to put it into a separate controller. I did just so we can try things out a little bit easier. But you can see we're getting the same data, ran about the same. So it's not about speed, it's about scalability. Do you know why you should subscribe to YouTube channels? You'll get notifications when new videos appear. You'll get recommendations for related channels. It helps the channel grow, which allows me to create more videos for you. It helps attract others to my channel. Your like helps others find videos that are good. So please take the time to like and subscribe to my channel, Paul D. Sheriff. Let's now add a method to get a single product. So again, open the iRepository. And let's add a new interface method here, the template for what it's going to look like. Let's go open our product async repository. So again, same type of thing. We're going to do a public async task of product, await _dbcontext.products.where.first or default async. So everything has to be marked now as asynchronous. We can then open our product async controller. And again, all we're doing on this is on line 66, we're adding the async keyword and the task as the return type. Entity equals await _repo.getAsync ID. And then we return the entity that comes back, or we return a 404 not found. Now off camera, I've already added the rest of the methods, the search, the insert, the update, and delete. Let's just take a very quick look at the code that I added. In the iRepository interface, you can see the search async, insert async, update async, and delete async that I added. Then in the product async repository, you can see the methods that I added here. The search async. We've got the insert async. Now on the insert and the update and delete, look at where I'm putting the await. The await is actually on the save changes async on line 56 there. And if we were to look at the update, we see the same thing on line 69. And down on the delete, same thing on line 85, we await save changes async. In the controller, so we had added the get async ID. We have now the search. We then have the post, and you can see the await here on the insert async. And we have the put, with again the await on the get async, and then the await on the update async. And then finally the delete, where we await on the call to the delete async. In this lesson, we made asynchronous calls that now run on a background task. Asynchronous in Web API improves the scalability, not necessarily the speed. We create two sets of methods in our Web API, one for synchronous and one for asynchronous. Not a bad idea to do, or just simply go all asynchronous. The choice is yours. Well, we've done quite a bit in this course. We've created a set of Web API endpoints, learned to use routing and dependency injection, called our Web APIs from JavaScript, configured Web API for cores, learned to secure endpoints using JWT, added logging and exception handling, connected API calls to a SQL Server database, and we tried out asynchronous calls. So where should you go from here? Well, you could learn more Web API programming by checking out my course on the minimal Web API. You could also just learn web programming, more MVC and Razor pages, HTML, CSS, and JavaScript. Maybe turn to desktop programming, learn some WPF, or Universal Windows Platform, or mobile development with .NET MAUI. My name's Paul Sheriff. Thank you very much for joining me in this course.